Welcome to the journey of machine learning. I'll be one of the instructor in this journey. So in today's session, we will discuss the history of AI and from and how the AI has evolved from that history to the modern day. Okay. So we'll try to give you a brief idea about the whole roadmap and the evolution of artificial intelligence and also history. Okay. So let's not do any delay and let's jump into our PPT and our board and let's try to understand how things gonna work. Okay, so let's jump there. Okay, I think right now the PPT is visible for you, and I will just make my video a bit of smaller than that you can see me properly, right? Okay. Okay, so I think right now that's quite fine. We can start our journey. So, by saying you best of luck, let's begin with our journey. So, let's begin our learning. Mm. So, when I say about the AI and machine learning and deep learning, you know, it all started from a young guy called Alan Turing. Okay, so you can see his picture. This is Sir Alan Turing. Okay, and he's kind of known the father of artificial intelligence. So at his time, he was not that famous, but as the time passed, especially after AI boomed, he became so famous. So let's see how he became so famous and let's know the whole story behind him. Okay. So if you want to know something in detail about Mr. Alan Turing or Sir Alan Turing, so you can watch a movie called The Imitation Game. Okay. So why this is called imitation game? Like in this session, you will understand why this is called the imitation game. But if you want more idea, you can simply go and watch this movie. So this is the biography of Sir Alan Turing. If you want, you can watch it and tell me later that how did you like how much you enjoyed the movie. Okay. So actually, the journey of Mr. Sir Alan Turing started from 1936 when he thought about the Turing machine. Okay. So he published a paper. So this is the front view of this paper. Okay. So he published a paper, and this paper started the journey of his life. So let's jump back to the 1936 about Sir Alan Turing. Okay. So at this time, mathematicians were asking a huge questions. So this question was a part of decision problem, and if you just go for Google, you will see there is one more term. This is kind of a German terminology. It's called Einsteinian problem. Okay. So in simple terms, what is Einsteinian problem? We wanted to know, can we find one single and magical method that can tell us whether any mathematical statement is true and false. So the question comes, what is this statement? Okay. Let's say if I say 2 plus 2 equal to 1. So 2 plus 2 equal to 4, right? So that's a true statement. But let's say there is a very big expression, or big equation. Okay. So there could be a machine, okay? If we just give any kind of questions, then it can simply tell us that is it possible to get the answer or not. Okay, so that is the main agenda of Turing machine. Okay, so let's see in details the stuff. Okay, so when Alan Turing came into this stage, okay, he thought a bit of different way. Okay, that no one did. He realized that before you can answer that, you have to define a method. How does what does it mean actually to compute something? Okay, what does it mean to compute? Okay, so he imagined a machine, not a real one, like what can I say, like an imagination machine. Okay, which has like a tape, like a roll, a paper roll, like toilet paper or whatever you can imagine. Okay, and divide it into squares. Okay, so what can happen? You can read and write. Okay, from using a pen or a head. Okay, we call it a head, but also you can call it a pen. Okay, like zero and one symbols, and also you can move it right and left. Okay. So I will simply just show you. This is called the Turing machine. Okay. So you can see, you can write on this, and also zero and one, and also you can move the pen right and left. Okay. And also you can write simple rules. For example, if you see one, change to zero, or move right like this. Like you can write just some simple rules, and you can just do this. Okay. This invention of Alan Turing is called as a Turing machine. So this machine kind of calls as also as a universal machine. Okay. So though it was imaginations of Alan Turing, it was not a real machine. So Alan Turing pushed it a step further. He wanted to see, can we build a machine that can solve any kind of problems? For example, let's say about your phone. It sometimes it works as a game console, sometimes it works as a port for listening music, sometimes that work as a camera. So one device working for multiple problems. So he wanted a machine which can compute any kind of problems. So that is called universal Turing machine. But at that time, Alan Turing told about a new statement or a new theory or new algorithm. That is called the halting problem. So what is halting problem? Halting problem statement can be computed or not. So from this experiment, he got the result that all problems cannot be computed. Okay. So from that statement, he got the idea of the universal Turing machine was impossible. It cannot be possible. After that, there was one of the like one great paper. I will come to that first, then I will come to this Enigma machine. Okay. So in that paper, this paper was published in 1950. Okay. So in this paper, first time Alan Turing introduced about the AI or artificial intelligence. Okay. So he asked a question that, can a machine think? Okay. So at that time, it sounded like a kind of a joke. Okay. Because in 1950, people can't imagine that there could be something like AI, right? So here, Alan Turing did a test. Okay. So he just keep one, as you can see here, one interrogator. Okay. And in one side he kept a computer, and another side he kept a human. Okay. So there was a response from both computer and human. And can the interrogator can guess which respond from the computer and which respond from the human being? So after a certain stage, he saw that yeah, the interrogator cannot differentiate the difference between a computer and a human. Okay. Even today also, if we want to evaluate some AI, we do this test. Okay. And this is also known as the Turing test. So these things were good, but at the initial days of Alan Turing, he was more into cipher. So what is cipher? Cipher is a technique to write English in a different way. For example, nowadays we all know about the crypto or encryption decryption. Like my name is Ayan, Ayan. So if I convert A to S, so it will be SYSN, right? So it's not possible for someone who does not know how to decode this to read. Okay. So during the World War II, what happened? I will just go to this part of the slide. During the World War II, Germany invented this machine called Enigma. Okay. So what is this machine Enigma? It sent the message from Hitler to German soldiers, but not direct way. It converts like a cipher. For example, if Hitler says, we are going to attack, it converts the whole message. Okay. So the British Empire could not recognize what the message is. So at the time, Germany had huge power. Even they had the technology. So the British Empire called a team with Sir Alan Turing. Okay. And they had to decode this machine. So what he did, he started imitating the cipher of this machine. Okay. And he tried to imitate. Okay. And then he tried to look for all possible solutions from those response. Okay. So that's where the name come, the imitation game. Okay. So what did? So he got the data from Enigma. From Enigma, he saw how many possible patterns can happen. And then he saw which patterns are making the more sense. And he keep continuing this. And from that, finally he found the pattern of the cipher of this machine. And finally he can grow the message of German. And even it's told that why World War II ended quickly because of Sir Alan Turing. If he was not there, so World War II could continue maybe more 5 or 6 years, right? So this is the story of Sir Alan Turing, and one of the greatest scientists, also known as the father of artificial intelligence. Okay, so next we will see about the more stories how AI came into play and how the field has evolved to more stuffs. Okay, so let's see. So the next great event was Dartmouth Conference. I think it is not the great, but the greatest event so far. Let me see why. Because so far, whatever people did, these were kind of not intentionally. They came into the path where they thought about something that can think by itself. But right now, like till 1950 or 56, there were different branches of computer science such as automata. They all were discussing about a machine which can think, but the whole thought process was not directed at the same path. So that's why there was an conference was organized in 1956 in Dartmouth College, known as Dartmouth Conference. Okay, so the that conference it was a gathering of world-based mind at that time. So it was a proposed conference for 2 months of 10 greatest minds. So Mr. John McCarthy, as you see here, he was one of the pioneer of this conference, and also Marvin Minsky, Claude Shannon. There were a lot. So right now the question comes: why this conference, right? So as I said before, that in different branches of engineering that time, people really started thinking, can machines think? Okay. But the thought was not directed in proper way. Okay. So Mr. John McCarthy thought, okay, why don't I bring some great mind and discuss with them and give a direction to the research of bringing a machine which can think by itself. If you imagine, it's just a couple of decades ago where, so it's not like these were the mind, like these were the people who can really see the future, you can say. Okay. So, in this conference, first time the field of AI was introduced. First time they used the word called AI, where they said that we can build a machine which can simulate the human intelligence. So the whole gathering was fragmented in 1956. So though, like as Mr. Macken suspected, it will be a gathering where we will discuss about the future of a thinking machine. But things did not happen the way they thought. Because see, you know what, what you think, it never happens the way you think, right? Because sometime what happens, like some people come late, some people come too early, some are interested. That's what happened, you know. And all the people who were there, they were great minds. Still, they all belong to different departments. For example, Mr. Minsky, he thought that we can work on neural networks. So you might think neural networks, but that we are doing right now, deep learning, it's come so late. So how we can talk about neural network at that time? So the thing is that the maths of behind neural network came in the 16th or 17th century. Okay, so this was the time, like 1980s or 2000, where we implemented in real life applications. So also neural network was in the existence at that time. Okay, and Mr. McCarthy was the pioneer. He thought, okay, we can work on the formal logics or the propositional logics. Okay, and Mr. Newell and Simon also focused on complex information processing. So they didn't have a fixed goal or a fixed way how they can proceed. So can I call it a failed conference? No, because these were the mind who can see the future. Okay, though they did not really get success, but at least they started the field called AI, right? So this was the field, this was the conference, what motivated other people to think like, okay, there will be a field where we can research unthinkable machine. And right now, the main idea was totally, but though they have different like paths, but still, the main idea was same. That to find some algorithms or some maths where they can build some machines which can think by itself. And and finally, which one is the most important is that I said before that it planted the optimism. So though it was not the best conference ever, but at least the first conference which gives the optimism to the people that there will be a field where people can found the machines which can think by itself or which can imitate the human intelligence, right? So it's quite exciting. So let's see what next, okay? Okay, so before we talk about more AI and stuff, okay, first of all, we have to know how we, even in modern day, how we are building those kind of super powerful AI models. Just because of computer chips, right? CPUs and GPUs. So we will talk about the GPUs in some later sessions. Right now let's focus mainly on the CPU because of course GPU is one of the most important part for building AI models. But right now, see how even computer chips become so powerful, right? So this is our next topics. How did computer chips become so much powerful? Okay, so this is a computer Intel chip. Inside every chip there is this kind of tiny, tiny transistors or switches. Okay, so if you follow you are kind of techie person, so you will know recently, Intel has launched some Core Ultra chips, which is built on 2 nanometer architecture. So, what is this nanometer architecture? Okay, this is the gap. This is the gap between two transistors. Because when they process thousands or millions of computations, it produce heats. Right? So we cannot just set up side by side, right? We have to dissipate the heat. Okay. So they are coming with some modern architecture. Like I still remember, kind of 5 years ago, I was using a phone with 12 nanometer to 14 nanometer architecture chip. Within 5 years, they have 2 nanometer architecture. Means what? They are reducing the distance between two transistors. So as they can reduce the distance between two transistors, at the same place, they can add more transistors. And in a chip, as many more transistor you have, the chip becomes more powerful. Okay. So what happened? From 1965, uh, the great scientist or Professor Muri, he has observed that in every year or maybe every 2 years, the number of transistors inside a chip was increasing twice. Means what? The distance between two transistors was decreasing, so the total number of transistors was increasing. Okay. So recently, I was watching some videos where in India we set up some kind of semiconductor factory where we found a chip with 28 nanometer architecture. So people were, I saw in the Twitter people were making memes and stuff like this. But you know what? Just in 5 years, we came from 14 to 2 nanometer. You know, and right now things are more advanced after 5 years. So from 28 nanometer architecture to 2 nanometer architecture, we might not need 5 years, 2 or 3 years. Okay. So yeah, we are in great direction to build new chips in our own country, right? So things are getting interesting, right? So we saw about the Alan Turing's, where he thought about a machine, how it can uh, build some logics, build logics. And then we saw about the conference where people thought about the machine can think. Now we see the hardware step. And by the way, this the scientist Moody, later he was a co-founder of Intel that you all know that we all use, right? So let's now we'll see how the later part are working. So next we'll see about the symbolic AI. Okay, so okay, sorry, I have just adjusted the screen a bit that you can have some better views. Okay, so let's continue our journey. So far, we have discussed about Alan Turing machines and also the Dartmouth Conference. Okay, so these all are the stuffs where we have only discussed about the notion, how people got the idea of artificial intelligence. Okay, so far we haven't talked about any real life implementation. Okay, right now we will see some how people started implementing AI in real life, means a machine which can think by itself. So at the beginning, it was not a machine it can think by itself. It was just a tool which can find the answer of the questions. Okay. For example, let's say right now, nowadays, if we have any doubt, any questions, what do we do? Simply we go to Google and search for the answers. Okay. So, but Google do some favor. It brings all the website where we can get the answer. But in case of AI, it does not have this kind of royalty. So it has to find the answer by itself. So there is a knowledge base, okay, and the AI has to find the answer from the knowledge base, okay. For example, let's see. So for that, at the initial days of AI, we mainly focused on searching techniques. Okay. Even if you go for data structures and algorithms, so you will also study all these kind of searches. So people thought we can implement AI by these kind of search techniques. Okay. So there are two kind of search: uniformed and informed and uninformed search. Okay. Informed and uninformed search. So what kind of these things are? Okay. Let me tell you. Let's say, let's say there is a knowledge base here. Okay, knowledge base here. Okay, your AI agent go to the knowledge base and looking for answer. Okay, let's say it does not have any idea about knowledge base what exactly the answer is. Okay, for example, it could be here, any point, right? It does not have any idea. Okay, so this is called uninformed search. Okay, means it is not informed, uninformed search. So we'll see some basic example of breadth-first search and depth-first search today. Mainly we'll focus on the breadth-first search, okay? And informed search. Let's say when the AI agent or have some idea about the knowledge base, not not exactly where the question, like the answer is, but some idea. For example, I asked the AI agent, find where is the apple, okay? So it knows that, let's say it knows there are four sections. In this section, all the fruits. In this section, all the vegetables. In this section, let's say all the drinks. In this section, something like this. So it will go to this section and do the search. Okay. So in case of uninformed search, the AI does not have any idea about the knowledge base or about the path, or we can also say path. Okay, but like if you go for like any kind of AI class, like basic class of AI, they use the path or state. Okay, but I'm saying knowledge base. Uh, Even in case of data structures, people use like path and state, But I love to use knowledge base. I'll say why within few minutes. Okay, you'll understand why I'm just saying knowledge base and knowledge base. Why I'm not saying the path and state stuff like this. Okay, so let's see one example of data search and how it works, and then we'll understand how we can implement the AI. Okay, so let's say we have a question. Okay, we have to. There are one, two, three, five, six, seven, seven cities. Okay. So the problem is we have to find the minimal path between A to F. So F is our starting point, and the F is our ending point. Okay. So we have to find the minimal distance between these two. So what we can do simply, uh, we can simply, first of all, apply depth first search. Okay, means first of all we have to look for the F. You know, once we look, we can find them. Then we say. So first of all, we look at this level. Yeah. Is there F? No. Then we will look at the second stage, second level. Yeah. So at first we check the B, check the sorry for my pronunciation. We check the B. Is it F? No. We check the C. Is it F? No. We check the D. Is it F? No. We check the E. Is it F? No. We check the F. Is it F? Yes. So we get found the F. And from here we get this path. Okay. We get this path. So you can say this is kind of a path. So right now the question comes, is it a shortest path or not? So in case of breadth first search, we cannot really say the shortest path because we don't have, let's say, from A to B, the distance is 25 kilometers. And here is 10 kilometers. But here it is 5 kilometers, it is 10 kilometers. So, so in this way, we'll get the answer at the first, but this is not the shortest path, longest path. So in case of breadth first search or uninformed search, we don't get usually the optimal answer, because we don't have idea about the path. At least we can find some answer. Okay. Let's say, okay, but these are the techniques, so at the beginning people tried. So next we'll start about the symbolic, and you'll understand these things is more detail. Like there could be a whole course on these stuffs. Maybe if possible in the future we will cover a detailed discussions about these kind of searching techniques. But for time being I will not be spending much time on this. Hope you get some basic idea what is this. Let's check about the greedy search right now. Okay, so it's an informed search. Okay, so in case of greedy search, see, we have the path distance. Means we have the idea about knowledge base, or we have the idea about our path or about our state. Okay. So what do we do the greedy path, greedy algorithm? In case of greedy algorithm, we always look for the shortest path. Okay. So let's say we start with B. Okay. So from B to C, we have to go 5, and then again we have to go 13. So total we have to go 17. 17. Okay. So the thing like this, in case of B to C, if you wanna go, we have to pay some taxes like 5 rupees, road taxes, and to enter in C city, you have to pay 13 rupees. Okay. So total you have to pay 17 rupees. Okay. In case of B to A, we have to pay 18 rupees. In case of E, we have to pay 16 rupees. So we have to see, we have to find the answer of a question. At what lowest cost we can reach to the G. Okay. Right now, if we go to the here, so you see 16 is the optimal path, right? The best solution right now. So we'll go to the here. So after that, we have only F, so we have to go here. Okay. Then here. Okay. So 16, then we have 6, then 10, 10, then we have 9, 9, then 3. Sorry for the handwriting a bit. So total is between 26, 35, 38 rupees you have to spend, right? Total if you want to go. Let's say if you could have choose this kind of bus, let's say B2C 17, then if I come here, let's say if I go there, 17 is 25, then if I just go here, 7, like 32, 32, 33. So if I take this path, look, my answer coming kind of 33. Okay. So what is in case of greedy search, like we don't get the optimal answer, like we look for the best solution at each step. Okay. So what happens, we cannot reach to the best solution, right? So there are multiple algorithms where we can play with them and we can found the best solution. So this is a part of traditional AI. If anybody is doing their BTech in artificial intelligence, they will study this subject in their second year. So Uh, so this kind of subject where you have the basic idea about AI, like how you implement AI at the initial days. Okay, so you have some problem statement and you have to find the answer. Okay, like if you have played the tic-tac-toe game, like tic-tac-toe game, let's say, uh, like this game. Okay, okay. So we can just simply like if I just make a cross here, what are the possible decisions I can take? Like one, two, three, four, five, six, seven, eight. Okay. So from then I have this one, right? Then what are the possible decisions I can take? Or maybe let's say in case of chess, you know. So I just took a move. So from that move, what are the possible moves I can take? Okay. So in which move I can get the optimal solution, right? So these kind of problems can be solved using this kind of graphs and trees and this kind of searching techniques. But if you think about here, what I said about the pricing or about the finding a city or tic-tac-toe game, or in case of this chess, these have in at each state you can only take um like a limited number of solutions, right? So like in case of chess, at a time you cannot have like 1,000 solutions, right? You have some optimal number of solutions, right? No, not lot of solutions. Same goes for here. From A, when you go from A to B, from A you have three solutions. Then B you have two solutions, right? So here at each stage the number of solutions are kind of in a certain limit, right? So you can go for such techniques, but so we can answer such kind of simple questions. Okay, so we can design a machine which can think about these kind of simple questions and answer, right? But let's say you have some complex problems. Okay, so how we can solve? Let's say uh, let's forget about the chess right now. Let's say uh, okay, so let's say we have here uh, like okay, let's take one example. Okay, so let's say a man here. I will just take one example here. Let's say a man. Again, sorry for my drawing. I am too bad at drawing actually. Okay, so let's say there is a man. Okay, there's a man. Okay, and he's eating some food. Let's say he's eating some vutta or some corns. Okay, some corns. Sorry for my drawing again. So I will give some input to my machines that is the person eating corns. It will say yes or no, right? Can it really answer? Because see, what is stage? There is no stage in this case. There is no stage. Okay, so like you will say, okay, so the person will bite the corn, then again come on, mazak mat karo yaar. Okay, it does not happen like this. So like uh, like from after biting the corn, it can take infinite kind of steps. It can do anything. The person can do anything, right? So we cannot think these kind of problems in this way. Even the main thing is how will you make a machine understand that it is a person, right? You can simply represent in case of if you have idea about the data structure, this is graph and trees. So you can represent the graph and trees or arrays possible. But how will you represent a person and a corn? How will you make a machine understand, right? That's the main problem. So let's see how we can do this. So for that, we came into symbolic AI. Okay. So symbolic AI is quite different than this machine learning, deep learning stuff that we are working nowadays. But once a time, it was like booming. It was rapidly booming, and people thought it's the future. It is the future, but it has some limitation. It had some limitations. So we will see what is this symbolic AI and what limitations. By the way, Do you remember when we all were kids? There used to be a gaming console. I think it costed like 200 or 300 rupees at that time, And there was a game called Pac-Man, there was a Pac-Man, this one, Pac-Man, and he used to eat all those kind of dots and these kind of germs. They used to catch our Pac-Man. So, if you are kind of born between 2003 or 2002 and 2005 or 7, you must have played this game. Okay. So, if you have played this game, you have already came across Symbolic AI. Okay. Or if not, you must have played this kind of chess online games. Even not, you must be playing some Ludo King and such games like play with the bot, or this kind of games, right? So you must have came across Symbolic AI. Right now you'll be excited, like, okay, I came across Symbolic AI. So what is this Symbolic AI? Okay. So our first problem was in our graph search technique was that we cannot really represent the real world data. Okay. Let's say we have a city, or let's say in case of chess, we have after one step we can have like five or six steps. Okay, we can represent by some numbers. But a person eating a corn, how will you represent? Okay, let's say A equal to person or B equal to corn. Then how will you represent eating? And how will you build some relation between them? Okay, it's impossible. It seems impossible, right? So the main agenda of symbolic AI was to represent the real world entity into symbols. Okay, what do I mean? Let's see. Okay, so let's say this is a book, this is a donut, this is a pot, this is a person, whatever it is, we will convert them into the symbol. Okay, so as you see here, symbols are how we are going to represent the problem in a computer, problem or even any entity, real life entity. Okay, it could be you, it could be me, anything. Okay, we can represent any kind of entity and problem. Okay, and using some symbols. Okay, and what is relation? Let's say a man is sitting and having a corn. Okay, so there is two entity, a man, a corn. Right now there is a relation. What? The man is eating the corn, right? So what is a relation? A relation can be an adjective that describe a symbol. Means what? The man is eating the corn. So these are the symbols. And what is relation? Eating. So the eating is describing these two entities or these two symbols. Okay. So these are called the relations. Okay. So here the eating is relations, and the corn and the man is a symbol. Okay. So what happens? Then we apply some logics. Okay. And we try to find the answer. We give an entity, let's say corn and a person, and then we give relation like eating. That means a man is eating a corn. Try to understand again. I give input like there is a man, there is a corn, it is a corn, there is a corn, and there is something, a relation called eating. So what the machine can understand? There is a man who is eating. Again confusing, again understand. Okay. I tell the machine there is a man, there is a corn. Okay, close the eyes. I just tell you, there is a man, there is a corn, and the relation is eating. What comes in your mind? Comes that a man is eating a corn. Try to understand intelligence. So when I say corn, a human, and the relation is eating, you're imagining that a man is eating a corn. Can a machine also imagine like you? That is the point. Okay. So I will say a machine, there is a person, there is a corn, and the relation is eating, and it will know that a man is eating a corn, right? So we are trying to build the basic intuition inside a machine. Can you feel the AI, how they want to implement? Okay. So at the first we saw about the searching techniques, where we have some basic questions and we're trying to build some logics or some searching techniques to find the answers. It means I just say you, what is 2 plus 2? You just simply answer me is 4, you know? So we are just, at the beginning, we were just trying to build this kind of intuitions, basic. Then we are trying to build more semantic intuition inside a machine. Okay. So let's see how we build actually. Okay. Let's come. So let's say, okay, by the way, so for I said there is a, we will represent the symbol, we will represent the relation and stuff like this. So for that, we all use some part of mathematics that is called propositional logic. I guess most of you have heard about this propositional logic. If you haven't heard, you will heard. Okay. So if you came across all like this OR and AND gate, the basic Boolean algebra, you'll understand. Okay, so you don't have to think that much for time being. Okay, even in this course, if we get time, we will see a bit about the traditional AI, but these are not in use nowadays. So people usually don't learn. But why I am covering, because I want to give you an in-depth intuition how these AI things came into the picture. Okay, so let's say you see the picture. There is a robot, who is driving a car. Okay. So what are the symbol? Like John Green is the name of the robot and car, right? So John Green is driving. Okay. And from the green, you can understand that the car smells of bad. So this is the also relation. Also, you can see the car is old. Okay. And we will see right now we have to apply the logics. Okay. And we have to look for the solution in the knowledge base. I think this part sound kind of confusing, right? What do I mean? We have to apply some logics, like you said. Try to understand what I mean. I tell you, there is a person, there is a corn, and the relation is eating. What do you imagine? You make some logic, you know. You try to find some patterns between among person, corn, and eating, and you try to build some logics. Based on that logics, you're imagining that a person is eating the corn. Try to understand. So the machine, I gave the input. Okay. I want the output, but what's the logic that's happening in the brain? Okay. So we will implement that logic using propositional logic. Okay. Let's see. So I want to build an intuition about the mind in the mind that like just intuition that there's a car which is smelly and old and driving by Mr. John Green. Okay. So let's say I just give the input smelly, true. So when it's true, I will say 1, and it's false, I will say 0. Okay. So if false, I will say 0, and true, I will say 0 or 1. Like, I will say 1, but it could be any number, like it could be 1 or 2. Okay. If any number, I will say true. Okay. So let's say I just give the input to the brain, machine brain. A smelly card means what? A smelly card. Okay. So, for like there is something called encodings. I will not go in depth, but for better understanding, let's say in the machine there is some buttons. Okay, some buttons for, let's say in the machine there is some buttons. Okay, 3 buttons. Okay, so first of all, first button for being smelly, second button for being old, third button for being John Green. Okay, so I push the first button, which is true. Okay, so the is smelly car, it's an old car, and also true, it's a car of John Green. So what we can you will think in mind that it's a smelly old car of Mr. John Gray. Do you understand what I mean? So what you can understand is a smelly old car of John Green. Okay. So try to understand the logic. You understood that a smelly car, a smelly car, okay, and an old car, and driving by John Green. Okay, I say. So true car and old car and driving by John Green. Okay. So what is and here? The connective. Okay, it is connecting the logics. Okay. So I just got, I just tell you a smelly car. What is smelly here? The relations. What's old here? Relations. Okay. And John Green driving a car. So what's kind of intuition coming in your mind? Is that an old car, a smelly car, driving by John Green. Okay. So when you connect all them using connectives and build a logic, what comes in your mind? A smelly old car driving by John Green. Okay. So I hope you understand how this kind of I right now want to grow some basic understanding, because I can teach you these things in depth. Like I need one lecture to teach these things in depth. Okay. So I want in your mind to grow the basic understanding, okay, that you can understand what is AI. Okay. So I hope you understood how the intuition has grown in the mind of the like like inside a machine. Okay. Inside a machine. So by the way, in case of in real life, by the way, we represent them using like some brackets. Okay, some brackets. Okay, like jacket. Jacket is what a symbol. So we keep the symbol inside a bracket, and we just keep the relation outside the bracket. Okay, but in real life we don't have such like only one and two. We have a lot of if else, right? If cold, then wear jacket. You know. So I just put inside the machine. Cold equal to true, wear true. Means it's cold, you know, and also wear jacket means what? Jacket we're wearing, okay, and it's cold. Try to understand. I say that I give input, it's a jacket, and someone is wearing. Means what? When I say something inside a bracket, it means it's a symbol. And what is outside the bracket is a relation. Okay. So jacket is wear by someone. Also, me or whatever the weather it is. Let's say it's a weather, okay? Weather cold. I say the weather. How's the weather? Cold. Wearing jacket. So what you can understand, if I add some connectives, if the weather is cold, then wear jackets, then also connective. Okay. So these are the part of propositional logic, if we get time how these kind of logics are coming, we'll see in details. Okay. So I hope you are understanding. So the thing is that in the knowledge base, like it is our knowledge base, right? This is one of the proposition we found. Okay. So in the knowledge base we have this kind of propositions. Okay. So based on our input, we go to the knowledge base and look for the logics or propositions, and based on that we give the answer. For example, let's come about the tic-tac-toe, or let's come about the chess. Okay. So we hire a chess grandmaster, and we build all the possible propositions of that chess. Okay. All the possible propositions. Okay. And then what we do, we just take the inputs, you know, and by adding some connective, some logics, if we get these kind of propositions, so yeah, I will say do it or else not. So hope you get a basic idea what is the symbolic AI. But in case of symbolic AI, the thing is that it breaks easily. It breaks easily because let's say you just make a you just make a machine for chess. But let's come to Ludo. It cannot work. See, it only can be designed for a particular system. That cannot be a universal machine that we have discussed in a Turing machine, right? And also, let's say about the about like whenever we are working like on in case of symbolic AI, all those proposition about the past, so we cannot generate something new, right? And nowadays the generative AI is on the trend. So the main problem of the symbolic AI is it's kind of limited, and secondly, it cannot generate something new. And secondly is ambiguity, you know, like let's say there is some if, like but or maybe, because proposition only give you answer true and false, right? It does not give you probability, like it may happen, may not, like for that we have also like markup chains and stuff. Okay, right now we will not discuss this, but let's come to the basics. Okay, so in case of proposition, it only gives you true and false. Okay, we don't have any probabilistic answer also, right? So in real life, is I think everything is a probabilistic. Right now, it will be raining. You cannot say true and false. If you make a weather predictor using symbolic AI, it will say true or false. It cannot say 90% chance of rain or 80% chance, right? That's why it's not kind of logical nowadays in real life. But yeah, but based on this, previously we have a lot of systems. We used to call them expert system. Okay, and let's say let's think at it. There is a cat and dog. Can you think a bit and tell me? Let's say there is a 5,000 pictures of a cat and 5,000 pictures of a dog. Can you tell me two difference between a cat and dog? You know, a cat has legs, dog has legs. Cat is has ears, dog has ears, right? There could be a small cat, big dog, small dog. You know. So in case of symbolic AI, you have to first of all represent the real world entity into a form, mathematical form. But if you do not understand the entity, how can you represent even? Let's say you want to build a self-driving car. Okay, so in a street, you can see thousands of objects. How you can represent them using symbols? It's impossible, right? After that, you have to find the proposition according to each element or each entity. That's kind of sounds impossible. So though in 1980s, symbolic and these kind of systems are called expert system. These are look to be the future, but it really did not work that much, right? It really did not work. So then the gang, like the gangster, came to the play. The probabilistic model, machine learning, and deep learning. Okay. So, so for what we have did, we try to find some basic answer of the question using searching techniques. We found the answers, but if the question is a bit complex, we cannot found the answers. So for that, we represent the entity into a symbol, and we create as many propositions possible. Like we create so many propositions according to that entity, and we store in the knowledge base. Okay, so we feed the input data to the machines, and it builds some logics and looks which proposition matches. Based on that, it builds the iterations. So this is symbolic AI. Next, come to machine learning and deep learning. Okay. So far, these all are the part of AI. So that's why we call the machine learning is a part of AI. Because AI is a big field. Also, there is called Markov models, Markov chains. In AI, we have a lot of things. Okay, but mainly in this course, we'll focus on machine learning and deep learning because these are the trend, and that's where the whole thing has changed. So one second, let me have some water, and we will begin again. Okay. So right now the question comes: what is machine learning? Okay. Again, let's again backtrack and see. In case of in case of symbolic or expert system, we have rigid answer, true or false. We cannot say like that much true or that much false, right? So that's why machine learning and deep learning are called probabilistic models. Okay? Because it gives answers in a probability, first of all. Second of all, try to understand what was the main problem in expert system. Okay. What we did here, Let's say there is a real world entity. Let's say there is a man. Again, sorry for my drawing. Eating a corn. Okay, a corn looks more like a knife. Okay, sorry for my drawing. Okay, so a man is eating a corn. We represent the man, and corn. These are the symbols, and what they are doing, they're eating. This is the relations. Okay, so we input that inside the machines, and we look for all the possible propositions. You know, so what's happening actually? If you look in detail, we input the data, and after that, we are looking all possible rules, and then we give an output. But the thing is that even in a simple cat and dog, we cannot find the rules. You know, so finding rules is the biggest problem. Okay, but machines are too good at calculations. Machines are too good at calculations. So if we can find a pattern between the input and output, let's say, I will give you an example. I will just, I'll give one example. Let's say I have output here as a cat, dog, cat. Okay, like this. And what we can input? The images. What are the things? Pixels. Pixels, pixels. So if I can found for which pattern of pixel is becoming a cat, or for which pattern of pixel is becoming a dog, can I found the rules? Means what? We have the input data, we have the output data. If we can find what is the pattern between input and output data, we have simply found the logics, right? We were looking for the rules so far, but in real life, we cannot always write the rules because rules are not feasible in real life because there are too many, and you don't know which object is in which stage, and after this time, in which next, what will be the next stage? We don't know, you know. So what we are doing, we don't care about, we don't care about the logics, the rules, because rules keep changing. We are trying to find the patterns between input and output data. So let's see again. So what is machine learning? Machine learning is a subset of artificial intelligence. So you all know this, where system learn and improve the from data without being explicitly programmed. Focus on this word, without being explicitly programmed. What do I mean by this? Let's say, in case of rule-based system, we have the input data, we have the input data, we have some set of propositions or rules, we have rules. Based on this, we have the outputs. Okay, that's even let's think about the basic C program, sum of two numbers. We just take value of A as an input, value of B as an input, and we just sum them A plus B, and we got the answer. So what? We have the input data, we have the rules, and then we get the answers. But let's just try to classify the cat and dog. Can we really find the rules? No, we cannot. Right? So at that case, what we try to find We have the input data. We have the input data. Also, we have the output data. Okay. And what is right? We try to find the rules. Okay. We try to find the rules. So finding the rules, this is the training of AI. What happens? Based on our data, AI find the rules. Next time, we don't have the output in real life. Okay. We have the input data and we got the rules from our training phase. You know. So we have input, we have output, we find the rules during the training. After that, when the training is done, we have the input, what we need output. So we keep the rules that we found from the training and pass the input through that rules. So we are telling machine, you found the rules. After that, we are taking that rules and we are sliding our input data through these rules. And we are getting the outputs. Hope you get my point. Okay. So in case of machine learning, we have input and output data and we try to find the rules. And when we train the model, we find the rule, we found the rules, we put them and we slide the input inside those rules. So this is during the training. And after training, what happens? Again, we have input data of real life. We pass it through the rules, pass it through the rules, these rules which we got during the training, and we get the output. So what's gonna happen? In case of cat and dog, we will try to find the pattern between the pixels coordinations of cats, like for which pixel coordination it becomes becoming a cat, for which pixel coordination it becoming a dog. Okay. Again, it's not only about pixel because right now, as we are beginners, we are just learning. I'm seeing pixels, but in when we will learn about the image processing, we will see we call them something called edges. Okay, like if we study, we will study about the convolution neural network. We will call them as an edge. But for time being, I'm seeing just pixels. Okay, because as a human being, I cannot see the pixels, right? But machine can. So I am trying to find for which pixel coordination it becomes becoming a cat, for which pixel coordination is becoming a dog. And after that, when I found the answer, I'm putting at the middle and I pass a cat picture, and it tells it's a cat. And I pass a dog picture, it's a dog. Okay, hope you get my point. So this is machine learning. Okay, so let's before like in case of symbolic AI, the main problem was to making a machine understand real world entities. Same in case of machine learning, like machine do not understand the words or human language. It only knows the like mathematical numbers. So even in case of machine learning also, first of all, when I say our input data, we have to convert them into mathematics. So uh, I guess you got some idea about machine learning. Let's see it a bit of more depth, you know, and then we will jump to more topics, because this is one of the topic. Like again, in the next session when I will teach you machine learning, I will say you again what is machine learning. But why am I taking this course? Before jumping into machine learning, you must have the idea, the intuition of machine learning, and how it came from those search techniques, those symbolic AI or expert system to machine learning. Okay, so I will take one example. Let's say there is a college. Let's say there is a college. Let's say you are the HOT of an university. Okay, so in the banner you wanna see the average package of your college. Okay, so simply what you can do, just think logically. You want to know the average package of your college. What you can do? Simply you can sum all the student like S1. Okay. Oh, what's happening to my hand today? S1. Oh gosh. Okay. S2 dot dot S SN. We can add all the students packages and then we can just divide. Okay. We can calculate the average. Okay. This is a simple way, right? We can answer the questions. But what's the problem here? Let's say there's a topper who just do a lot of hard work and he knows the average package is only 5 LPA. He'll be depressed, like, oh gosh, why am I studying that much? If I only get 5 LPA, and let's say there's a backbencher, he knows nothing. He'll be like, even though if I die, nobody gonna come to look at me. So if I get 5 LPA, it's good for me. So he'll be so happy. So it's not good, right? It's injustice. We are giving some wrong intuition to the people about the package. So what we can do that if you tell me your CGPA, let's say your CGPA 9.1, 9.1, then your package will be like let's say 20 LPA. Okay, 20 LPA, 20 LPA. Okay. Like if I ask you if the price of 5 pence is 10 rupees, what is the price of 10 pence? Simply you can add some unity methods, and you can simply tell me, right? But let's say you have a data in such a way, okay, I will not be wasting time by like drawing whole data because let me pause the video for a while and let me draw it and then I'll be back. Okay, just give me a second. Let me draw it. So I'm back with our data. So as you can see in the data, we have CGPN packages. Okay. So if somebody gets 9.1, 20 LPA, 8.1, 16 LPA, 7.8, 15 LPA, 6 CGPA, 12 LPA. Okay. So right now, as I told before, if you have 5 pence, price 10 rupees, then 10 pence, how many rupees? Simply you can apply the unitary method and you will get the answer. Right now, can you apply? Right now, I only have 4 rows. Let's see in real life, in real data, I have 1,000 or let's say 10,000 rows. At that case, can you apply such kind of logics and find the answers? Yep. No. Simply impossible, right? So what I mean actually that like always finding rules is not possible. Like even in the cat and dog picture we see we cannot find the rules because the observation is beyond of our capacity. Same here. We cannot, as a human being, we cannot observe 10,000 or 1,000 rows. We cannot observe, right? So the observation is beyond of our capacity. So that's why what we do, we say the machine, you know what? You have such a good capacity, you are good at mathematics. But you know what? I'm smart. I cannot write logics between CGPA and package. For what CGPA, I can get what package. But I can tell you how you can find the patterns between the CGPA and package, and give me that patterns. Once I find the patterns, I will input the CGPA, I will get the package. Same like I have the pattern. I input cat image, it says it's cat. I input dog image, it says it's dog. And if you don't have a good model, you input cat, it says a dog. You input dog, it says it's a cat. Okay. So let's see. Okay. So in this graph, I try to represent all those kind of data in a graphical format. Let's say it's a CGPA and these are packages. So as you see, as the CGP increases, also the package increases. So here, if the CGP is the highest, the package also is the highest. Okay. So what I want a general answer. Okay. So I want the patterns between the CGP and package. Okay. So what I can do, like how machine can really get the pattern? Like machine can get because it has the capability to observe. I only have to tell the machine how it can observe. How? Let's say if I draw a line like this, which goes kind of close to all the points. Okay, not kind of at the top, like kind of shading all the points, kind of near to the all points. Okay, so what's happening? Not accurate, but we are getting a general answer. Like let's say somebody getting this kind of CGPA. Okay, so this is the actual CGPA, actual package. Like okay, just give me a second. Somebody getting this kind of CGPA. Okay, so this is the actual packet he can get. Okay, but if I can draw a line, okay, so what it tells that this is the intersection, so it tells this. Okay, so kind of close, right? So we if we can draw a line, you know, a line from where, if we calculate the distance of the all point, let's say the distance from this line to this point, this line to this point, this line to this point, this line to this point. So if I found such a line, okay, where the distance of this line from all the points is minimal, then this line can represent a pattern between what? The CGPA and the package. And once I can get this line, let's say I just have a new CGPA. Let's say somebody says, this is my CGPA. I will just draw a line. And so this is your package. This is, if this is your CGPA, that's your package. Okay. So machine can, we cannot observe, but machine can observe, right? So I tell them, you know what? Observe them and find this line for me. And once I get this line, okay, this I will be like, okay, that's good. So this is machine learning. So in case of machine learning, what is this? Like we will see this kind of stuff, okay, where we have to draw some lines and stuff like this. But right now the question comes for then what is deep learning? So if I go to deep learning, it says that where it is deep learning. Okay, I forget to add deep learning anyways. Okay, so what is deep learning mainly? In deep learning, we see this kind of you know artificial neural networks. So what is the problem with machine learning? That again we have to go in more depth and we have to look for the deep learning. Okay. So in this problem, you see like if I say CGPA 8.1 or 8.2, I can say any CGPA, And in case of package, I can get any number, any number. Let's say 8 LPA, 12 LPA, 18 LPA. So there is not means it could be anything in a certain range, So these kind of problems are called regression problems. But let's say true and false. Like if I turn this data set, let's say I don't call it package, I just call it placement. Okay, placement, placement only. Okay, and if his placed is one, else zero. So let's say one and zero. Okay, so how then I can simply present a graph like this. So these are the people who did not get placed. Cross mark people did not get placed. Did not get placed. Okay, did not get placed. And if I say right mark people, they got some placement. And if I can draw a line which can separate them, okay, what I can say, if someone is this side of the line, like at the top of line, means they will get placed. And that side of the line, so mainly I have to find this line, like I have to find this line, right? But you see, these data linearly separable. What do I mean? We can separate this kind of data by single lines. Okay, but there will be a lot of, let's say in case of this data, we cannot kind of separate them by one line. There's a one point always, in this part or that part. And look at this data, you can never like draw any line, you can never separate these two data, right? So when you cannot do not separate two different kind of data by one single line, we call them non-linearly separable. Okay, and we can separate them. We call linearly separable. So in case of machine learning, it is possible, but we usually do not prefer. Like it's not that much beneficial. When we have non-linear data. Machine learning really does not work that well on non-linear data. Okay, even the image data are unstructured data is a quite non-linear data because let's say in one image we have 1080p cross 1080p pixels, or let's say any kind of, how many pixels and 10,000. So this is gonna have kind of 10,000 dimension. Right now we are just looking up the two dimension, and let's say if I add here one more column, let's say I add here one more column called IQ. Okay, so it gonna be into 3D. Okay, so it gonna be into 3D. Okay, so if is that it is 1080p cross 1080p, so there will be 1080p cross 1080p dimension. Like if I do just sample mathematical, just it gonna be like 1080p cross 1080p. Hope you can see this, like this much big number. It gonna be this much big number, this many dimensions. Okay, so it gonna be so complex and too hard to handle for machine learning. Okay, so that's why we prefer deep learning. So what is deep learning? It's kind of same like machine learning. From the basic function is same, because again machine learning deep learning also comes under machine learning. Okay, so as deep learning also comes under machine learning. So same in the deep learning, we have input data, we have oops, sorry for this. We have input, input data. Also we have output data, and what we find, the rules. Okay, the same technique, but there is something different. What is different? We work mainly on non-linear data. Okay, in case of machine learning, by the way, in this whole course we will study about this a lot of machine learning algorithms, like some are supervised, unsupervised, and reinforcement. I will say what these things are: supervised, unsupervised, and reinforcement. I will discuss in detail after I talk about deep learning. Okay, so there is one machine learning algorithm called perceptron. Okay, perceptron. This is also machine learning. Like it works on nonlinear data and only get to one line. Okay, so as we see in such data, one line is not enough, right? So there is a machine learning algorithm called perceptron. Okay, we will see in detail what is this perceptron, how it works, the maths behind this. We will see in detail. But right now, just we'll know the basics, like perceptron. And if you see, it kind of same look like our human neuron. This is our neuron, and this is our like perceptron. This is our neuron, and this is the structure of the perceptron. They're kind of same. So, like from one perceptron, we get one line. So we create a stack of perceptron that we can multiple lines, and we can separate also the nonlinear data. Okay, so we call them as a multi-layer perceptron. Okay, so it is called the input layer. It is called the output layer. These are called the hidden layer. Okay, we will see these things in very details. Like this is the stuff I really like to learn, as well as I like to teach. So the good news is I'll be teaching you this. Okay, so be ready for this. Okay, this is called to just have fun. Okay, just understand a bit. Okay, so this is called the multi-layer perceptron, and we also call it artificial neural network. Also, we call it artificial deep neural network. Okay, right now, if sounds scary, so forgive me. I just wanna make some intuitions. I just wanna give you some roadmap what we can learn in this whole course. Okay, so this is called perceptron. So this machine learning and deep learning can be divided into two parts. First of all, supervised, unsupervised, semi-supervised, and reinforcement. Okay. Here, like in case of machine learning, it's only like supervised, unsupervised, and reinforcement. So these are all the machine learning algorithms we will like study. So in case of regression, we will study linear regression, support vector machine, descent tree, lasso, and ridge regressions. And okay, just you can simply see this. Okay, we will discuss all these stuffs, okay, in the part of machine learning. But yeah, in case of reinforcement learning, I am not sure how much we can discuss. Like if we have time, we will discuss the reinforcement learning. We have to know the markup chain rules, q learning, r learning, all the stuff. These are quite interesting stuff, but if we have time only, because we have first we will jump into deep learning, then if we get time. Okay, So what is supervised learning? Okay. So let's say in this data set, we have CGPA and we have the placement or package. Okay. So what is CGPA or input? What is the package? It's out. So in the data set, if we have a CGPA, like the input and output both, okay? So in machine learning, we call all the input as a feature and the output as a label, okay? So if we have the label in the data, we call them supervised. So from the word supervised, you can see there is something called some supervision, right? Supervision. So why this supervised come and what is the connection of supervision with the label, right? Let's see how actually I'm just telling you find pattern blah blah blah. What is this pattern and how exactly the AI get trained? Okay, so let's see in this video. So let's say there is I take this first column. Okay, I just turn on. I just input CGP. Okay, 9.1. Okay, into my AI model. So right now what I'm doing, I'm asked like I want it I want it to learn the patterns between the input and output data, means features and labels. Okay. And what is my job here? My job here to help him to patterns. Okay. Like to give the data and to find some a format that you can learn. Like as I saw you that show you that uh, they found a line. So machine does not know it has to find the line. Okay. So I will define using mathematics that you know what I cannot observe 10,000 rows. You can observe. So I'm asking you, you find this best line for 10,000 rows. Okay. So what it has to do, I'm telling. Okay. So let's say my goal is to find this best line. Okay. For 10,000 rows. So what is this line actually? We can represent a line using the equation called y equal to mx plus c. Okay. Mx plus c. So, what will be the x here? X is our input, you know. I say the CGPA input this. And y, what is y? Y is output, our package or our like placement. Okay. What's M and C? M is the slope of this line. And what is the C? C is the intercept here. So M is the slope and C is the intercept. Like if you I hope you know because these are the class 11 and 12 maths and still if you have some confusion we'll cover this whole thing in very details. Okay, right now I want just to have some basic intuition. Okay, so what's happening here? So so like the position like this can line can be here, this line can be here, can be here. So for having this perfect position of this line, okay, so this position depends on the value of m and c. So we can see here that we have to find the proper value of m and c that we can get this line. Okay, so our goal is to give all the data to the machine and ask it that you know what, for these 10,000 rows please found the best value of m and c for me. So how it can, so you start from a random value of m and c. Okay, so I input 9.1 and it has, what is 9.1 here, our x. Okay, and it has some random value of m and c. So random value of m and random value of c. Random value of c. Based on this, it just makes some prediction. Okay. We can just call it y hat. We also can call it y pred. Let's say it says the package is 24 LPA. Okay. But what was the original y? 20 LPA. So what we do, we just make, we just ask it, you said it's 24 LPA, but in the data it's only 20 LPA. So what? We already have the input and output. Okay, and we have to find the best value at m and c. Okay, so we start from a random value of m and c. Based on the X 9.1, we just do the prediction and it says 24 LP. Let's say. And then we say, you know what, machine? Whatever you are telling, it's wrong. It says, okay. The machine says, okay, it's wrong. So tell me how wrong it is. How much wrong? So what I can do, I can simply do y minus our y prediction, right? So I can calculate the error. I say you are that much wrong. It says, okay. Then what you have to do, machine? So machine said, I have to change the value of MNC. So based on this, it changes the value of MNC. Again, it goes to the next column, 8.1. It makes a prediction. Let's say it's 17 LPA. Originally, it's what? 16 LPA. I guess the machine, you are wrong. What the machine say? Okay, tell me how much wrong I am. I say this much wrong. It say, okay, it's my duty to shift the value of MNC again. So it's going like a cycle, and we call it as an epoch. Okay, in case of machine, we call it as an epoch. So it's going as a cycle and cycle, and yeah, that's how we try to get the optimal value of MNC. Okay, and next time when we have the X and the best value of MNC, we simply can predict the Y, right? So hope you get the basic idea of machine learning and deep learning. Okay, we will discuss them in very details again. But right now, I want to have some basic intuition that how it works and the basic idea, and that's all. Okay. Again, if you do not understand, try to again see the video again and again. Okay, because this is a core concept. Okay, I will discuss again, but in this introduction video, I want you to have some basic intuition because next time when I will make you understand, you have a proper clarity about what you are understanding. Okay. Next, okay. So this is a quote I really like. You know, when it comes to neural network, it can learn anything as long as you can convert them into number. Like it can learn human language, it can learn anything, anything. When I say anything, is anything. Like it can learn DNA patterns, it can learn about the blood cells, it can learn, but you have to represent them in a particular format, like mathematical format. And also you have to know the neural network structure. Like in case of machine learning, we just saw we have to find a line. Okay. But in case of deep learning, we have to find this kind of complex, like neural network architecture. Okay. So if we can find these kind of proper logics, like we have to find the lines, or here we have to find the proper neural network architecture, then neural network or machine can learn anything. Because nowadays, just see ChatGPT, how good it is, right? How good it is. So, after this neural network, again, the neural network has a lot of parts, like some are designed for like image classification, some are designed for text classifications, right? So next one thing we'll study in the future is called convolution, that even I talked before, convolution neural network. So it is a special kind of, like I was telling you, there is a 1080p cross 1080p image, and if I simply multiply, it would be like this much. Let me reduce this much dimension. It's really hard to handle this much dimension. So what we do, we just reduce these images into a lower dimension, but still we have all the details, all the features. If there is zebra, there is a zebra, but in a lower dimension. Sounds like a magic, right? I want to have this curiosity though. I like it. So in the future, we'll see how does this whole thing works. And CNN is one of the most favorite topic for me, at least, because I think it's just a magic, and you can understand it simply. And not only will understand CNN, like it's a basic theory or basic architecture. Based on this CNN, there were a lot of models, like I told you, like to make a to make a machine understand, we need a proper neural network architecture. So later there are a lot of neural network architecture like ReNet, AlexNet, PGNet. We will see all those architectures in the future. Okay, and these all are trained on a huge data set because again, Machine learning and deep learning, they are data hungry. We need to feed a lot of data. You know, you can ask which one need more data, machine learning or deep learning. That I will see in the next video. Okay. We need some suspense for the next video, right? So not everything in this video, not everything. Okay. So what we do, like first of all, we can train this neural network on huge data. Let's say, like in case of ImageNet, there are 1,000 classes. Means if you train the like AI model on this data, it can classify 10,000 like 1,000 species or objects. Okay, like cat, dog, umbrella, like this. Okay, and after, let's say, then I want only classify cat and dog. Then I can fine tune. Like, you know what? Maybe you know a lot. I can say the machine. You know a lot, but I don't need this. I only need cat and dog. Okay, this is called fine tuning. Okay, so we'll see how we can fine tune this model and predict. And this is the future. Like when you will be working in an industry, you have to know how to work on the pretend models and how to fine tune them. Okay, like this fine tuning concept come from this computer vision, like this computer vision on CNN actually, you know. And later, if you have heard about the NLP, this fine tuning what is quite famous. So we'll see also the fine tuning of LLMs and stuff like this. So everything will be there. Okay. So these are some architecture. Next comes with the GANs. Okay. So GAN was the beginning of, you can say, generative AI. Okay, so there was, like, I forget the name of the inventor, but one day he was a bit drunk, you know, and he thought, why, if the neural network can learn anything, why can it generate? Okay, so he created this network. So what's happening here? There is a generator and discriminator. So what it does, the generator keep generating some random images, like fake images, you know, and the discriminator said, you know what, it's a fake, it's a real fake, real fake, real fake. Okay, so every time the generator generate a image, discriminator say, you know what, it's a fake image. So then the generator said, okay, it's a fake, but how fake it is, how fake, how much fake, it says that much fake. Again generator improve this, again it says it's a fake, again improve this, and improving, by improving step by step, right now the generator can generate such a great quality images, you know, like it can generate new images, you know. So from there, these like generative AI came into the picture, you know. And there is one more model called diffusion model. Like we'll see in the future. Right now I'm just giving you some basic introduction, you know, what these things are. Next comes with the RNNs. Like let's say I say you, I'm going to schools, and I say, school, I am going blah blah blah, going school, am I, whatever it is. So in case of image classification, the sequence was not a big fact, you know. Even one pixel go here and there, it does not matter that much. But in case of text, the sequence is so much, like, is a big factor, right? So like I think, so this is a neural network architecture where we learn how to keep, or how to arrange the word in a proper sequence, right? So this is called recurrent neural network. Okay. Next we have like transformers. Okay. So what happens? So in the 1990s or 2000, these RNN were quite famous. You know. So a lot of chatbots were built based on these RNNs. Okay. Let's say you wanna talk with RNN, like, you know what, like, hey, how are you, like this, like you can talk with Google Assistant or Alexa. Okay, you can build also, because I told you RNN can process text, you know. But what happens if the text is too long? Let's say you tell me, like I tell you, you're such a nice person that I like to talk to you. You're going there, but I'm not doing this. Blah blah blah. Like I keep telling. Okay. So if the line is too long, then this RNN cannot remember this line. Okay. Means it can work with the text, but kind of like me, bit less memory. Okay. Whatever it is. So RNN cannot remember long string or long sentences, right? So that's why the transformer came into the picture. You know, and this is a paper called Attention You All Need. You all should read the paper, or even in these codes, we'll cover this Attention You All Need paper, because it is one of the greatest invention humanity could have. And today you see all these kind of like GBT, BART, Grok, DeepSeek. Oh, by the way, how many people was cursed by the Grok? Because a few days ago, Grok was cursing people in the Twitter. Okay, even it cuts me, whatever. So, so Grok cuts me just for this paper, which you all need, okay? So we'll cover this, okay? So what even there is one more specialty about this like transformer. It can capture the semantic meaning. Let's say a dog and puppy. Puppy means a small dog. So Aranian cannot understand a puppy and dog are quite same. You know? A puppy means a small dog. A queen means a female version of a king. You know, the Aranians cannot understand, but that's what can be understood by the transformers. Even let's say I say State Bank of India and River Bank. Both are bank, but they're different meanings, right? So the onion cannot understand. Same word could have different meanings, but the transformer can, you know. So that's why nowadays this GBT and things are booming, you know. So this paper came in 2017, and after that, the AI started booming, you know. So I think this paper is a kind of pioneer. Like this is, I think for me, is the best paper ever. Okay. So next we have the BART and GBT. So this is home task. Okay, for the next session. So before you join next session, I want you to do some research on what is BART and what is GBT and how they are different. Okay, we will discuss for sure. Even it's written here, kind of. Okay, okay. But for timing, I would say do not see it. Take it as a home task. If you like this, if you like my teaching so far, just go and Google and read what is BART, what is GBT, and how they are different and how they works. You know, that's how you learn. I told you, you have to ask question to yourself, right? Next, we got DeepSeek. You know, like so. In case of transformer, there is something called attention mechanism. Like like it pay at like River Bank and State Bank of India. You have to pay so huge attention in every word, right? To find the difference between like our mind can, but how can a machine do, right? So that's where this attention came. But after DeepSeek came, the Nvidia stock fall because where ChatGPT spent billions to train their models, um, DeepSeek trained the whole model just in a 100 GPUs, right? So then people thought, okay, we don't need NVIDIA anymore. So the stock came down. So they use something called latent attention, not only attention. Okay. So what is this actually? This is also an attention, but in a lower dimension. Okay. So what happens? The training become faster. So if we have time, also I will teach you this in very details. What is multi-head latent attention? Okay. And also, as I told in case of computer vision, we also have here pre-training and fine-tuning. Like first we train the model on huge text, like the whole text of the internet, then you can tune them as per our use case. Let's say I want to make a spam classifier. So I will just tune it that it works as a spam classifier. Or I want to make a chatbot. So I will just tune it as a chatbot. Okay. Next we got here small language model. Okay. So far we have talked about the large language models. They are trained on huge data. But if we train the transformer in small data, it does not really work well, you know, because what I say you have to pay a lot of attention. So to get the attention, you need a lot of data, right? You need a huge data. But still, if there is not that amount of data, still, can we build a language model? Why? Because it's efficient. It can speed up. It could be, let's say, uh, like even right now TCS Wipro do not prefer to have use ChatGPT. Okay, so if we can build a language model using their data, small language model, so their people can also use like AI in their field, right, in their office. So can we build a language model on small data, and it will work as good as a large language model? So yes, we can build. Not as good, but still you can build. So we'll see this. We'll even if we get time, we'll do some hands-on practical how we can build some small language model from the very scratch. Okay, and then we have agents. Agents are nothing but AI with tools. Okay, so if you have ChatGPT and if you give some tools, let's say you have ChatGPT and you just give the access to your Gmail, you can simply go and send a mail for you. Or let's say you can just give the access to your web browser. Simply you can go to the browser and browse the details. Okay. So the AI with some tools is called AI agent, which can work for the human beings. Okay. And lastly, we have AGI. This is what is a new trend. So AGI, what is an AI model which can right now is kind of like a fictional, like it's an AI model which can work as good as a human being. Okay, and one is like a super AGI, which is like a like have you watched the movie Robot? Chitti, do all the stuff. So this kind of like an AGI, or maybe there is some spaceships in the space. Like if you have watched Band Tension, like there is Wilcax come, and also Gwen Tennyson has this kind the her grandparents who are kind of work with the mana and like the magic, like all those stuff in the Band 10 that you see. The Omnitrix of Band 10, he just tap and become an alien, right? So all this stuff kind of, so it's kind of science fictional, our science fiction, don't think much of this, but we can think about AGI, like a machine which can think like a human being, takes its own decisions and stuff like this. So thank you so far. This was our course, and thank you for joining, and best of luck for the whole journey with us. And this was our first day, and just give me the feedback. How was the sessions? And if I can do some improvements, tell me. And sometimes I just try to make a bit of fun. So then don't be serious because yeah, it's important to have some fun sometime, right? So for time being, bye bye, take care, and see you in the next session. Bye bye.